Hi everyone, this is Saranya, Assistant Professor, Department of Computer Science from Dr. S.N.S. Rajalakshmi College of Arts and Science. Today in our lecture series, we are going to see the topic recursive language in theory of computation. First of all, recursive language means one of the important language in theory of computation. First, we consider language L as recursive. The word recursive is none other than decidable. If L is a set of strings accepted by some Turing machines that holds on every input, that is called a recursive language. For example, when an Turing machine reaches a final state, it halts. Halts meaning is none other than stop. We can also say that Turing machine M halts when M reaches a state Q and a current symbol A to be scanned, so that lambda Q comma A is undefined. There are TMs that never halts on some inputs in every one of these phases. So we make a distinction between the language accepted by a Turing machine that holds on all input strings and the Turing machines that never holds on some input strings. Now let us see the recursive enumerable language. A language L is recursively enumerable if L is a set of strings accepted by some TM. If suppose language is accepted the string by some Turing machine is none other than we used to call recursive enumerable language. If suppose we consider string as W linked with language L, then a Turing machine holds in a final state. If it is not equal, then a Turing machine holds in a non-finite states or loops forever. Looping process will keep on repetitive. So if L is a recursive language, then if W is equal to the language L, then a Turing machine holds in a final states. If suppose it's not equal, then Turing machine holds in a non-final states. So recursively enumerable language is none other than if any Turing machine can be designed in order to accept all strings of the given language, that particular language is called as recursively enumerable language. For example, recursively enumerable languages or we used to say recursive languages as well as regular language, context sensitive language, and then context free language, and many more is known as recursively enumerable language. So in that recursively enumerable language, we have many properties. It's none other than closure properties. We have some many properties in order to perform under regular language, right? So regular language as well as context free language, recursive language. So here in recursively enumerable language, we used to follow these kind of properties. Properties is none other than union, intersection, and then complement. So union is none other than we used to compare the two language, combine two languages together. So that is called as an union property. Intersections, we have, suppose we consider two languages. So in that language, we used to check over the equal string. So that is called as an intersection. We are going to perform the intersection property in order to select the common one among the two languages. So that is called as an intersection. So complement is none other than A dash B dash. Likewise we studied in mathematics, right? So that is if suppose one language is not, that particular string is available when compared to another languages, so that particular thing is known as a complement. So these three properties are very important among the recursive enumerable language. So now let us recall the topic recursive language. Recursive language and recursive enumerable language, more or less the recursive language is commonly we used to call as an enumerable language. Not only recursive language is enumerable language, we used to call context free language, context sensitive language is all combinedly called as an recursively enumerable languages. So thanks for your patient listening. If you have any queries, please try to contact me. Once again, thank you for your patient listening. Thank you.